Ladies and gentlemen, welcome to BASF at K 2025. Welcome back to our plastics journey. I'm really looking forward to this plastics dialogue because it's such a fascinating topic with two fascinating experts here. Dirk-Jan Kostra from Biome Renewables. Did I pronounce it correctly?
You pronounced it correctly.
Thank you very much. And Kai Brüning from BASF. Gentlemen, glad to have you. Glad you made it on time.
Yeah. I was a bit running, but okay.
Okay. But you're in shape. You can do it.
Yeah.
Wonderful. So we're going to talk about how to reduce the noise for wind turbines, and that has a lot to do with nature, with a fascinating idea, and with a very smart material choice. But Dirk-Jan, maybe you introduce Biome first of all to us, so that we know what your company is about.
Yeah, Biome is a young company. It's actually was founded in Toronto, Canada, and it focuses on biomimicry, basically looking at biological solutions that exist in nature, and how we translate that into technical items to provide solutions. Currently, the main office is in Toronto. We also have an entity in Amsterdam, the Netherlands, from which we support the European market. And our focus is on basically North America and Europe.
Okay, so the application you copied from nature this time, you copied from a very specific animal.
Correct.
Yeah, and that is an
owl.
Okay.
It's, if you realize that owls, if they fly at night, you don't hear them, and you start wondering why don't we hear them, and it's about the feathers of the owl, and we try to mimic the feathers of the owl and see how we can translate that into solutions for wind turbines. And wind turbines, as you know, they're a good solution in the energy transition, but they get closer and closer to our homes. And people start to complain mainly about noise. So the idea from our founder, Ryan Church, was basically to see can we use the owl technology and translate that to a solution for wind turbines. And that is the item that we have on the table here, which is in the booth, which is called the FeatherEdge.
FeatherEdge. I love it how you just said the owl technology.
Yeah, it is.
a very nice way to put it. That's a fantastic idea. How did BASF get involved?
On a very typical way, let's say, they sent us an email with a request for a very special product with outstanding properties. And then we had a phone call, and I decided that we have to meet. And then Dirk-Jan explained me, all the properties which our material has to have, and that was the beginning of this project.
Okay, that was the beginning, and how did it continue?
Sorry?
How did it continue after that beginning? Testing, development, new products? Tell us a bit more.
Yeah, then we thought, okay, we have to find the right product, and this is for us at BASF Polyurethanes. We know about that. We are always searching for outstanding properties, and this we know our elastogran products meet these properties, and then I'm not really familiar, let's say, with the wind turbine business. But I have somebody I know for private, and I asked him about this products and about the demands on the product, and he said these values are very outstanding, and he definitely likes to test this product.
So the first testing was done at a wind farm near you?
No. It's actually, well, let me just kick in.
Yeah.
When we started the project, we didn't know really what material we had to go for. We looked at traditional materials, the ABS, the ASA, but we have a product that basically is in the outdoor continuously. But one of the tricks to mimic the feather, because if you look at existing products of serrations, as they're called as a general term, in wind turbines, they're very stiff. And the idea we had to reduce the noise, the part has to be flexible and stiff at the same time. So when we started the project, I had a printed part And of course, material suppliers ask me, what properties do you need? I said, I don't know. I need something that does this.
That was your description.
That's where we started. So we started with materials. Initially, we started with thermoset polyurethanes in a casting process, for the simple reason that as a small company, injection molding is a huge investment. So we chose a process that is fairly low cost to develop and gives us the opportunity to change. And we did change, because this is the second generation of parts. And now we're in the phase that we say, okay, the geometry is fixed, we know that it works, and now we're moving towards an injection molded part, the thermoplastics. And that's why we talked to BASF about the application of TPUs. And currently we're going through a testing program, because being exposed to nature, there's a lot of UV radiation, there's a lot of flexibility. You have to realize that on a wind turbine, the technical lifetime is about 20 years. Customers ask, can you provide something that lasts for 20 years? That's a bit challenging. But translating the vibration into a technical part, the amount of vibrations that we see will probably exceed 100 million. So we're very challenging on the material choices. And I think that's where Kai helps a lot.
Kai, did you have the right material at hand? Could you just take it from the shelf?
Yes, we have. We have very different grades of thermoplastic polyurethane, and you can imagine these parts have to withstand very high demands are needed to do this. And regarding temperature, for example, they have to be flexible at very deep temperatures. Regarding weathering, like UV resistance, like hydrolysis resistance, and also the mechanical properties of these parts have to be on a very high level, because you can imagine the speed at these blades are very high. And yes, we have products. We are optimistic that we can meet the demands of this product.
Dirk-Jan, let's get back to the actual application. I understand this is a prototype. You're testing it. You're testing it now.
Yeah, from the let's say we are in a phase that with the casting, so the thermal sets, we are able to provide our customers. But the demand is so high, the interest is very high, that we have to look at methods that we can basically increase our production rates. And that's where thermoplastics and injection molding is playing a role. I might say that 2 weeks ago we signed a testing agreement with Enercon, one of the largest wind turbine manufacturers in Germany. They're very interested in our product, and the rest of the OEMs are looking in it as well. So from that perspective, we're looking at the OEMs. At the same time, we are able to provide, say, the aftermarket, the wind park operators who have, as they call, curtailment, basically stopping wind turbines at night because of the noise. Now, putting these on basically means that they can spin during the night, create more energy, create more money for them as well.
So I'd like to get back to the actual sound or noise reduction contribution. If you're pitching it to OEMs or to the aftermarket, you tell them normally it's this decibel, and now it's
standard serrations of the OEMs do somewhere between 2 and 3 dB sound reduction. We exceed, depending on the turbine, we're somewhere between 3 and 6. And one of the larger machines that we currently tested, we had 3.7 dB noise reduction.
Okay.
Meaning 3 dB noise reduction basically means 50% less noise.
Yeah.
So it's a logarithmic scale, and so the results are very, very good to hear.
Yeah, awesome. Kai, for an application as crucial as wind farms for the energy transition, wouldn't it be great if we could also use a really sustainable material?
the customers have to decide this, yeah. But sustainable is always a point of discussion, yeah. Yeah.
If it passes the validation program, we'll be the first to apply it.
Yeah, okay.
But we have to prove it because, let's say in the material development, we've been on the conservative side. Being a small company, dealing with larger OEMs, we have to be absolutely sure that it works. Do we want to make it sustainable? Absolutely.
I'd also, one question allow me on the cooperation between a small, visionary, fast-driven company and BASF. Did that always work smoothly?
Yeah, actually, yes. It's on.
You can tell the truth here.
No. Actually, yes. Let's say dealing with large corporations, it's a matter of finding the right door. And I think with Kai, I found the right door to into the organization, and from there on, they basically help you further. But you have to have a story, and not just a story that basically is a pie in the sky. But in this case, I think it was, we had a part. This is what we want to make.
Exactly.
That helps.
Exactly. That definitely helps. That also helps here and also at the booth because you can have a look at a prototype, not only this one, but also a small wind turbine here. You know that K-Fair is happening every 3 years. So I think BASF will be back here in 2028. And we would like to invite you again already now. But what are we going to talk about? What's the situation going to be like in 2028?
I think our application has run through Europe. We probably look at an optimization of the product, probably good recyclability of those materials. But I think hopefully you'll hear nothing, because then we show that the product works.
And then it's also less sound. Kai, what are we going to talk about in 2028?
Yeah, it would be good if this project is running and we can give support and applicate it to other products in this area.
And make some money together.
That's a good idea.
Yeah.
Let's talk about that back in 2028. Dirk-Jan and Kai, thank you so much for sharing your insights. You're going to be around for quite some time to have a silent conversation with all of you, and you can test that piece. Thanks for your attention, and thank you.
Thank you very much for the invitation. Thank you.
BASF. We create chemistry.